Hello students, today we will solve chapter 7 coordinate geometry, and this is your part second. In this video we will see the first formula from the chapter coordinate geometry. Your first formula is distance formula, and which type of distance we will find here. We will find here the distance between 2 points. Let's suppose this is your point A having the coordinate x1 y1, and this is your point B having the coordinate x2 y2, and we have to find the distance between A and B. So let's start. First, let A x1 y1 and B x2 y2 be 2 points, and we wish to find the distance between A and B. So plot these points on 2D plane. This is your x-axis and this is your y-axis, and here is your point A having the coordinate x1 y1, and this is your point B having the coordinate x2 y2. So now draw a perpendicular line from A and B on the x-axis. This is your perpendicular line, and the intersection point of x-axis and y-axis is origin, and the coordinate of origin is 0 0. And the most important thing is any distances on, I am talking about 2D plane, so any distances will measure from the origin. So this is your point C and this is your point D. So what is the distance of OC? So the distance of OC will be x1, and distance of OD is x2. Similarly, the distance of OA is equal to y1, and distance of OB is equal to y2. Now draw a line from A to BD which is parallel to CD. Draw a line from A to BD which is parallel to CD. So here you can see that AEB is a right angle triangle because angle D is 90 degree and AE is parallel to CD. Obviously angle E is 90 degree. So in right angle triangle AEB, using Pythagoras theorem, AB square is equal to AE square plus BE square. Now put all the values of AE and BE. So the value of AE is equal to the value of CD. So now you will find the value of CD from here. So the value of CD is equal to x2 minus x1 whole square plus, and the value of BE, this is your BE, and this is equal to this value. So this length will be equal to y2 minus y1 whole square, or AB is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square unit. And I am telling you one thing is distance can never be negative. Distance can never be negative. So use a symbol mod in this formula, and the properties of mod is properties of mod. This is the symbol of mod is any integers or any real number as a input in mod. Any real number as a input in mod, then it will give a positive number, a positive real number. For example, mod 4 is equal to 4 and mod minus 4 is equal to is also 4. Now you can write this formula like this: AB is equal to under root x1 minus x2 whole square plus y1 minus y2 whole square unit. I hope you will be better understand of about this formula. So now I am going to solve exercise 7.1. The first question is find the distance. Find the distance between the following pairs of points. This is your some points from the exercise 7.1. The first number is 2 3 and 4 1. So I am going to solve the first question. Let A 2 3 and B 4 1. So the distance between A and B will be equal to under root x1 minus x2 whole square plus y1 minus y2 whole square. This is your point x1 y1 and this is your point x2 y2. Put all the values of x1 x2 and y1 y2. 2 minus 4 whole square plus 3 minus 1 whole square. This will be equal to under root minus 2 whole square plus 2 whole square. Under minus 2 whole square is equal to 4 and 2 square is 4. This is equal to under root 8 and this will be equal to 2 under root 2 unit. Similarly, see the number second. The number second is let A minus 5 7 and B minus 1 3 is the given point, and we have to find the distance between A and B. So AB is equal to under root x1 minus x2 whole square plus y1 minus y2 whole square. This is your point x1 y1 and this is your point x2 y2. So put all the values of a b x1 y1 x2 x2 y2. So this will be equal to under root x1 minus 5 minus and x2 minus 1, then minus and minus plus 1 whole square plus y1 minus y2 7 minus 3 whole square. The overall result is minus 5 plus 1 is minus 4 whole square plus 7 minus 3 4 whole square. This will be equal to under root minus 4 square 16 plus 4 square 16 is equal to under root 32, and the square root of 32 is 4 under root 2 unit. Now see the number third. Let A AB and B minus A comma minus B. So the distance of AB is equal to under root x1 minus x2 whole square plus y1 minus y2 whole square. This is your point x1 y1. This is your point x1 y1, x1 y1, and this is your point x2 y2. So put all the values of x1 y1 x2 y2 is equal to under root a minus, and x2 is minus a, minus and minus plus a whole square plus y1 minus y2 b minus, and y2 is minus b, minus and minus plus b whole square. This will be equal to under root 2a whole square plus 2b whole square. 2a whole square is 4a square. 2b whole square means 4b whole square. Taken 4 as a common, and bracket a and a square plus b square, and the square root of 4 is 2 under root a square plus b square unit. Now see the second question. Find the distance find the distance between the points 0 0 and 36 15. Can you now find the distance between the two towns A and B discussed in 7.2? As you will see in section 7.2, section 7.2 is just like your question number second. So this part and this part from the section 7.2 is same. So the solution is, let A 0 0 and B 36 15 be 2 points, and we have to find the distance between A and B. So distance of AB is equal to under root x1 minus x2 whole square plus y1 minus y2 whole square. This is your point x1 y1, and this is your point x2 y2. Put all the values of x1 y1 and x2 y2. This will be equal to 0 minus 36 whole square plus 0 minus 15 whole square. 0 minus 36 means 36 whole square plus 15 whole square, and the square of 36 is equal to 1296. 1296 plus, and the square of 15 is 225. 225. This will be equal to under root 1521 unit. Here you can take the, or you can find the prime factor of 1521, and the pairs number comes out from the root, so both answer will be same. Now see the number third. Determine if the points 1 5 2 3 and -2 -11 are collinear. So let's see. Let A 1 5, B 2 3, and C -2 -11, -2 -11 be 3 points. Be 3 points, and we have to check the all given 3 points are collinear. Collinear means all the points lie in the same line. Suppose this is your line, So plot these 3 points on this line. This is your point A, this is your point B, and this is your point C. If all given points are lie in the same line, so we can say that all points are collinear. And how will we prove the collinearity? The best method is we have two different method to prove collinear. First, uh, using distance formula, and second, using area of triangle. So I am taking I am talking about here using distance formula. So according to distance formula, if distance of AB plus distance of BC is equal to distance of AC, so we can say that all 3 points are collinear. That is, distance of AB plus distance of BC is equal to distance of AC. So let's we will find the distance of AB, next distance of BC, and next distance of CA. So first I am going to find the distance of AB. AB is equal to under root 1 minus 2 whole square plus 5 minus 3 whole square. This will be equal to under root minus 1 whole square plus 2 whole square is equal to under root 1 plus 4 is equal to under root 5 unit. Now the distance of BC is equal to under root 2 plus 2 whole square plus 3 plus 11 whole square. This will be equal to 4 whole square plus 14 whole square. 16 plus 196 is equal to under root 6, 6, 12, 9, 1, 10, 1, 11, 1, 1, 2, 212 unit. And the distance of CA is equal to under root minus 2 minus 1 whole square plus minus 11 minus 5 whole square. This will be equal to minus 3 whole square plus minus 16 whole square. This will come out 9 plus, and square of 16, the square of 16 is equal to 256. This will be equal to 9, 6, 15, 5, 1, 6, and 2. So you can see that this is the larger distance. So according to condition of collinearity, the sum of all smaller distance is equal to the larger distance. So according to condition, AB plus BC is equal to CA. Put all the values of AB, BC and CA. Under root 5 plus under root 212 under root 212 is not equal to under root 265. Hence, given 3 points are not collinear. Given 3 points are not collinear. Now see the question number 4. Check whether given 3 points are the vertices of an isosceles triangle. This is your first point. Let A 5 minus 2, B 6, 4, and C 7 minus 2 be 3 points. So what is the definition of an isosceles triangle? A triangle in which two sides are equal. A triangle in which two sides are equal. So that triangle is called isosceles triangle. Suppose ABC is a triangle. If in triangle ABC, if two sides are equal and third is different from the two sides, so ABC is an ABC is the vertices of an isosceles triangle. So you have to find here the distance of AB, BC and CA. So first I am going to find the distance of AB. Distance of AB is equal to under root 5 minus 6 whole square plus minus 2 minus 4 whole square is equal to under root minus 1 whole square plus minus 6 whole square. Minus 1 whole square is 1 and the square of 6 is 36 is equal to under root 37, and the distance of BC is equal to under root 6 minus 7 whole square plus 4 plus 2 whole square. This will be equal to under root minus 1 whole square plus 6 whole square. This will comes out 1 plus 36 is equal to under root 37. And third, you have to find the distance of CA. The distance of CA is equal to 7 minus 5 whole square plus minus 2 plus 2 whole square is equal to under root 7 minus 5 is 2 whole square plus 0 whole square. This is your 4 and this is 2. Here you can see that these two distances are equal from the third side, that is AB is equal to BC is not equal to CA. So and hence given 3 points are the vertices of an isosceles triangle. Now see the next question, question number 5. The question number 5 is, in a classroom, four friends are seated at the point A, B, C and D. Four friends seated at the point A, B, C and D. As shown in figure, Champa and Chameli walk into the class, and after observing for a few minutes, Champa asks Chameli, "Don't you think ABCD is a square?" Chameli disagrees. Using distance formula, find which of them is correct. According to Champa, ABCD is a square, but according to Chameli, ABCD is not a square. So you have to find and you have to check which of them is correct, either Champa or Chameli or both. So in this case, we have to find the distance of AB, the distance of BC, the distance of CD and the distance of DA. If all distances of AB is equal to BC is equal to CD is equal to DA are equal, so we can say that ABCD is a square. ABCD is a square. So students will try to solve this question, and I am finding all the coordinates of the point A, B, C and D. So the coordinate of A will be the coordinate of A is equal to the distances on x-axis is 3 and distances of y-axis is 4, so the coordinate of A is 3 comma 4, and the distance of B is coordinate of B is, this is your 6 and this is your 7, so coordinate of B is 6 comma 7, coordinate of C is 9 and 4, the coordinate of C is 9 4, and the coordinate of D is, this is your 6 distances on x-axis and 1 distances on y-axis, so coordinate of D is 6 comma 1. So students, I am saying again, students will try to solve this question, and also you have to try to solve the question number 6, 7, 8, 9 and 10, and all these questions will solve using the distance formula in this, and next video we will see about the section formula, and also we will solve exercise 7.2. Okay, thank you for watching.